Hi everybody, welcome to the webinar for industrial hygiene. My name is Ryan Dignard and I work for Airborne 1 as an occupational hygienist. Today the webinar will be focusing on monitoring and reducing exposures to chemical and physical agents. And as I was saying in the beginning a few minutes ago, everyone will be muted during the presentation, and any questions you might have can be input into the chat, and we can deal with them at the end of the presentation. And if you have any questions, we'll deal with it at the end. So let's get started. And again, thank you for joining us. So the outline for today's webinar will be to discuss industrial hygiene, get an overview of what that is, Occupational Health and Safety Acts and Regulations, the exposure limits. For Ontario, they are OREG 833, dealing with TWA, STEL, and sealing limits, the OREG 490 for designated substances, and for noise, OREG 381. We're going to look at sampling methods. We'll take a look at lab analysis results and interpretation of those results, hazard controls, and industrial hygiene updates on the regs and any OELs. So what is industrial hygiene? It is a specialized area of occupational health and safety, and the goal is to ensure protection of workers from health hazards arising from their work and environment and work practices. The goal is to identify hazardous situations in the workplace, to evaluate the degree of risk, and to recommend control strategies. And those workplace hazards might be chemical, physical, or biological in nature. So we'll start off with one of the big ones, which is chemical hazards. These might be in the form of vapors, such as solvents like toluene, acetone, formaldehyde, trichloroethylene. They might be isocyanates if it was a painting operation, or spray foam operation, or in adhesives. You might have gases like carbon monoxide, hydrogen sulfide, methane, chlorine. You might have fumes from metallic fume from welding operations, mists from oil mists, for example. You might have just a dusty environment, so we might measure for inhalable particulate matter or respirable particulate matter. So those are two size fractions that we want to focus on. But you might have some more specific dust, such as wood dust or silica, which requires some special concern. And then moving into the future here, we have nanoparticles being developed more and more. So questions are coming up are, do our current methods and occupational exposure limits account for these? So moving down the road, we might see limits for nanoparticles. The two regs that would apply to chemical hazards are OREG 833, control of exposure to biological or chemical agents, and OREG 490 for designated substances. And just a note that you really need to know what you're sampling for, which we will discuss later on how to make sure you're doing the right type of sampling. But for something like isocyanates, you might, even though it's in vapor form, you might need to sample both vapors and aerosols. So it really requires some thought about what you're sampling and how you're going to do it. What about odors, and where do these fall into the regulations? Odors refer to the ability of our sense of smell to detect the presence of a chemical or group of chemicals. However, the regulations do not discuss odors and do not indicate requirements for employers to mitigate nuisance odors. Detection of a chemical by its odor does not necessarily mean that a health hazard exists. However, there are a few cases where the odor threshold is above the OEL, like isocyanates, for example. And there's a few examples out there, and that can be problematic because by the time you're smelling the chemical, you could be overexposed at that point already. So odors may give the perception of poor air quality, and the employer is likely going to have to evaluate the odor to satisfy the concern. Hygienists compare results from the air sampling to minimum odor thresholds for single compounds, but not for mixtures or whole odor. So when we get the results back, we can see which compounds are either above the OEL or above their minimum odor threshold. We also have physical hazards in workplaces, such as noise, temperature, even lighting, vibration, radiation, maybe, and maybe there's some ergonomic issues. So all of these can be evaluated to ensure the workers are not being harmed in any way and aren't presented with any hazards. Noise is probably one of the biggest ones that are measured as a physical hazard. For biological hazards, you might have bacteria such as Legionella or E. coli. You might have mold issues and some genus of molds there, Aspergillus and Stachybotrys. You might have workers who are outdoors, and so they might encounter harmful plants such as hogweed or poison ivy. People working outdoors might also be in contact with insects and who are vectors of disease. Might spread West Nile, or ticks might spread Lyme disease. And for those people who are in the healthcare industry, you might have communicable diseases, and they have to be worried about spread of flu or SARS or mumps. So lots of different things to be concerned about from a biological point of view. And there's various organizations in industrial hygiene. There's the Ministry of Labor, who governs in the industrial hygiene aspects of work for Ontario. We have CSA as well, who's involved with setting some standards. We have ACGIH out of the U.S. They provide us with standards as well, exposure limits more specifically. OSHA is out of the U.S. They'd be similar to our Ministry of Labor. They have some standards they've set as well, and you can also get some sampling methods from them. NIOSH, they have a set of standards which we don't really follow, but we could use as reference. But NIOSH is a great resource for sampling methods. AIHA is one other organization, and HSC is out of the UK, so they can be used as references as well. So for Canada and Ontario specifically, we have federal regulations. If you're a federal regulated workplace, you have the Canada Labour Code, the Criminal Code. You have some other acts like the Hazardous Products Act or the Transportation Dangerous Goods Act. In Ontario, we have the Occupational Health and Safety Act, which is monitored by the Ministry of Labor. That little book that you can see on the screen is the Pocket Ontario OH&S Act and Regulations book. It's very useful. It has all the act. It has the act and all the regulations within it, and so it's a great reference tool. You can find out the occupational exposure limits if Ontario has set those, and it tells you what to do in the case of you don't find an Ontario limit, you would go to ACGIH for other limits that are available. Within the Act, you can see that there's sections such as Section 25, which is a general duty clause, and so a lot of people are found guilty of this when there's been an accident or a death, and they don't take every precaution reasonable to protect their workers. So it's important for due diligence to be due diligent and avoid this charge. There's workers' rights under the Act, so there's the right to refuse or stop work where health and safety is in danger, and there's a right to information regarding health and safety. There's Joint Health and Safety Committees, there's WHMIS, and those are all listed in the Act. And then there's basic OH&S awareness training that came into effect in 2015 that's required by Ontario workers. So the Ministry of Labour enforces the Act and its regulations, and so their inspectors can enter a premise without a warrant or notice, and employer must make workers available to them and show them what they need to see. They might issue orders, which are specific written requirements to tell the employer what needs to be done to comply with the Act or regulation. And they might ask for something like air sampling or other hygiene tests to be done. And sometimes with severe infractions, they might issue fines immediately to the company or to individuals for something like poor guarding or PPEs not being worn, something like that. So you must comply with all the orders or face legal penalties. And those fines are listed in that booklet, and there's several different types of fines, which might equal several hundreds of dollars. And Bill C-45 was added to the criminal code quite a while ago now, but it increased the fines to an organization from $25,000 to $100,000 for some offenses. And there's also penalties for individuals convicted of criminal negligence causing death. So Bill C-45 under Section 217 states that everyone who undertakes or has the authority to direct how another person does work or performs a task is under the legal duty to take reasonable steps to prevent bodily harm to that person or any other person arising from that work or task. So in other words, if you have responsibility to direct another person, it's your responsibility to protect that worker and make sure that they are doing things safely, or you could be held liable. So let's switch gears a little now, and we'll talk about airborne contaminants and their health effects. So the respiratory tract is the target organ and route of entry for many pollutants. Other routes of entry exist, however, such as the skin or through ingestion. However, the OELs are based on inhalation exposures. Exposure to pollutants can compromise lung function, may have effects on cardiac function, or can cause damage to other organs or sites as pollutants are transported via the bloodstream. So even though the route of entry may be, say, the lungs, for example, other organs or systems within the body can be affected. So for example, repeated inhalation exposure to high levels of trichloroethylene can affect the central nervous system, including the auditory nerve, potentially impacting a person's hearing among other effects. This is especially harmful when accompanied by a work environment that has high noise levels. So this chemical might be referred to as an autotoxin because it not only affects your nervous system but also can impact something like your hearing, and when you have high levels of noise, it's sort of compounded, so it's additive. VOCs in general affect the brain, the CNS, heart, and liver. Metals if you have metals exposure, you're susceptible to lung diseases and central nervous system effects. For example, manganese exhibits Parkinson's-like symptoms. If you have asbestos and silica exposure, you might develop lung cancer over time. So the exposure regulations, OREG 833 and 490, specify over 725 different exposure limits. There's 140 in that green booklet, or about 140. It changes from time to time. There's always new ones added, or sometimes there's some taken away. And then there's about 680 in the ACGIH tables. And what we'll find there is, TWA, which is the time-weighted average, the STEL, and the ceiling, which we take into consideration if these limits exist for a particular compound. So they're all very important. Time-weighted average refers to airborne concentrations of substances and represents conditions to which it is believed that nearly all workers may be repeatedly exposed day after day without adverse health effects. And that's based on an 8-hour day or a 40-hour work week. For the STEL, it's for short-term periods. The sampling is based on 15 minutes and should not be occurring more than 4 times a day with a gap of 60 minutes in between. So these are for non-routine tasks within an organization. Maybe they're opening a drum of something or cleaning something, and they get a little bit higher exposure. So you're allowed that little bit higher exposure for short durations. But it should be noted that your overall TWA for the shift should also not be exceeded. And then for the ceiling limit, that's just a concentration, a max concentration that should never be exceeded. And that's difficult to measure. You usually just do a quick short-term sample in order to measure the ceiling. There's also excursion limits, so when a STEL or a ceiling limit doesn't exist for a certain compound, there's rules on what you can do for that. The TWA multiplied by 3 can be the excursion limit for a STEL, and the TWA multiplied by 5 can be the excursion limit for the ceiling. Under Reg 490, we have 11 designated substances listed here. So these are 11 substances classified as such because of their inherently toxic and harmful characteristics. And they're subject to special treatment in workplaces in accordance with a set of substance-specific rules and regulations. And these used to all have their own individual regulations, but now they've all just been consolidated into OREG 490. So regarding sampling strategy, questions to consider are, why are we doing the sampling, or what are we going to sample, or how are we going to do it, where, when, who, etc. So here's the answers to some of those. You might be doing it for compliance reasons, or to address concerns, or for control, design, and evaluation. We might be trying to identify hazards or do a risk assessment. How might we sample? Well, portability and convenience might be a consideration, or how quickly do we need the data, or specificity. Where might we sample? The area of concern within the facility, the breathing zone of the worker. Is it a personal sample, an area sample? Is it at the source of the contaminant? Do we do it during the day or night, or specific day of the week? Is it under worst case conditions? So all things to take into consideration. Which percentage of workers do we sample? Is it those at greatest risk, or is it just random? And for sampling, you might collect, a full shift sample. So that's like a 1 8-hour sample, or you might, get consecutive full periods, or you can decide on how you want to collect the samples. But when you do that, you might be increasing costs. So you just need to know what the sampling plan is going into the facility. So exposure determination, here's some examples of what we might use to collect samples. We have, hopefully you can see my pointer, we have sorbent tube media, which would be used with an air sampling pump. And here we have some filters down in the bottom left. And so those would be used with an air sampling pump as well. We call that active sampling. And the device, the middle of the bottom, something like a Q-Track, is a real-time data logging instrument. So that would give you data immediately and record those values for later download. And in the bottom right-hand corner, we have examples of a noise dosimeter. This is a new style. This is an older style noise dosimeter to determine a worker's exposure to noise. So continuous sampling using a real-time instrument. It gives you the data in real time right on the screen. It also data logs. You might need this if you're using or entering a confined space. That's actually really important that you are using that to determine oxygen levels, or if there's an explosive environment, you would want to know that right away. It can also help in determining peak exposures. It can also help you find sources. So if you're doing something like leak testing or source testing sort of thing, where you're just looking for a contaminant's source. Continuous monitors may include, from the left, we have a PID, an IQ monitor in the middle, and on the right is a CO monitor. And there's also devices out there to measure real-time dust levels. If we're not using a continuous monitor, we'll likely be doing integrated sampling, which requires the use of a pump and sorbent media, or, as the bottom picture shows, a passive sampler. So this is the collection of air over a fixed period to assess overall contaminant concentration. So that's used to determine the TWA or the STEL. So the average concentration equals the mass of the contaminant, and we get that number from the laboratory in milligrams or micrograms, for example, and we divide that by the total air volume collected in cubic meters. So our units will be milligram per cubic meter, possibly microgram per cubic meter, and conversions can be done to get that to parts per million. So again, active sampling with pumps and media, and passive sampling with something like this device down here, which is a passive sampler, and the sorbent media is within this device itself, and it regulates the flow rate through the membrane. Passive sampling is kind of nice because it doesn't require pumps, which can run on battery and can break down and run out of juice and things like that. They're also less intrusive in certain situations. So for laboratory analysis, it's preferred if you use an accredited lab to conduct the analyses. Labs that are accredited have gone through audits of their quality control procedures and documentation, and they regularly participate in proficiency testing to ensure that standard practices and levels of competency are met and maintained. So if you're here in Canada, we have CALA, which is the Canadian Association of Laboratory Accreditation. This is an accreditation that our company, Airzone, holds. So for many analytes using NIOSH methods and EPA methods. You might also be accredited by AIHA for different analytes, NIOSH methods, OSHA methods, asbestos, biologicals, etc. I should note that the CALA and AIHA use the ISO 17025 protocol. There's also Standards Council of Canada that can do accreditations. Okay, what analytical methods might you need to use? There's quite a few of them, and it depends on what you're measuring and detection limits, things that you might need. So for dust, you will use a gravimetric method. For VOCs, you might use GCMS or FID. Metals, ICP, AES. Asbestos is microscopy. And silica, for example, is X-ray diffraction. So we'll get into those a little more detail now. So for particulate matter, we use the gravimetric method. Essentially, all we're doing is weighing the filter prior to use and post-sampling to get the mass of the dust loading. And here's an example, the first picture of a climate-controlled clean room, so we want to minimize dust contamination. Here at Arizona, we have two balances that we use a microbalance to the microgram range. It's a 6-place balance, and we also have a semi-microbalance to 4 decimal places. And other analytical methods might include, something like for asbestos microscopy. There's a couple different types of microscopes that can be used. Phase contrast microscopy, which determines total fiber load. It can't really differentiate between asbestos or other fibers. Or if you need to know exactly, your asbestos concentration, you would use transmission electron microscopy. And of course, there's cost considerations for those two methods. For metals, it's ICP AES. Silica is X-ray diffraction. Isocyanates is HPLC. So you really need to know what you're sampling, how you're sampling it, and then that'll determine which methods you're going to be using. The labs out there will help you if you have questions on what to sample with and which analysis to use. So for gas chromatography, it's one of the most widely used analytical techniques. It separates components of complex mixtures using a coiled tubular column, which is in the second picture here. This circular looking object is the column. I think they range from about 15 to 30 meters within that coiled column there. So due to differences in mobility, sample components separate into discrete bands that can be analyzed qualitatively and quantitatively by a variety of detectors. So the GC with its column and that's within an oven, those are doing the separation, and then you have a detector to detect the individual compounds or ions that are coming off of that or out of that column. And those different detectors are listed here. Flame ionization detector or a mass selective detector. You might have an electron capture detector for something like halogenated compounds or PCBs. An FPD is for sulfur or phosphorus compounds, and the TCD thermal conductivity detector is for things like oxygen, nitrogen, etc. So if you're doing VOCs, however, you're likely the analysis is being conducted by FID or MSD. The gas chromatograph is produced, and this is an example at the bottom. The various peaks are the individual compounds that have separated out at specific times, so we call those retention times. And the analyst will determine the area under the peak in order to get the concentration of the specific compounds. So calculations and results interpretation, we get the mass of the contaminant from the laboratory in milligrams, for example, and we have the total volume of air determined in the field doing pre and post cal of our pumps using a certified calibrator. This is a picture of two calibrators, and we have the sampling time. So we have the flow rate, and we have the sampling time, and we have our volume. And as we discussed earlier, the mass over the volume will give us our concentration in air. And a lot of the times we give the volume right to the lab, so the result we're getting back is already in the units we require. So the hygienist will compare results to the OH&S regulations, the OELs, including the TWA, the STEL, or the sealing. We might have to use the Ontario limits or the ACGIH limits. Or if none of those exist, we might find reference limits from other agencies such as OSHA or NIOSH or WHEEL, and we just use those as a reference, and although they're not enforceable within Ontario. There's also something called the action limit, which is it's not really an established guideline. It's not enforceable, but it's a best practice. It's when an individual compound reaches 50% of its exposure limit, and so it's a good point to start considering what you could do to mitigate the air quality contaminants and try to reduce those before something like ventilation or production levels change and airborne concentrations increase, and you might reach the limit or exceed the limit. So it's just a good point to start being proactive and thinking about reductions to the air contaminants. Control strategies. So the main methods of control of a contaminant in the workplace, in this order preferably, is elimination or substitution methods, engineering controls, administrative controls, or as a last resort, PPE. And we'll go over these in the next slides. So for elimination, what we mean is eliminating the hazard, providing this is an acceptable business decision. So you would stop using that toxic material, or stop producing a product that has toxic materials, or stop making loud noises from a particular process. You might even just outsource the work, because by outsourcing the work, it's no longer affecting your workers. So you're physically eliminating the hazard, and it's no longer going to be a problem at your facility. Substitution, what this is doing is just replacing the hazard with something less hazardous. Again, provided this is acceptable to the business. So you're going to use less toxic materials. For example, if you use lead paint, solders, adhesives, something like that, you're going to use alternatives that don't have such hazardous materials within them. You might change the process. So say you're spraying something, you might switch to brush or tube application. So it's less likely to become airborne. And then you might work with wet work methods to reduce dust generation. So you might hydroblast instead of sandblast. You might also have to install some engineering controls. So these controls contain, isolate, or shield processes of concern in enclosed systems, and with appropriate ventilation if necessary. The ventilation might include general dilution ventilation or local exhaust ventilation, where you have a capture hood near the process. You have to consider the direction of the ventilation. So is it an updraft ventilation or downdraft or cross flow? You would consider all of these and just ensure that it's away from the breathing zone. So the last thing you want to do is bringing the contaminant from its source across the person's breathing zone. So you're actually exposing them further to contaminants. And you must also consider, the strength of the ventilation, so its flow rate, its balance, and ensure that that there's enough capture velocity in order to work properly and capture those contaminants and take them away from the zone. And just of note, if ventilation air is exhausted via facility stacks, this leads to other environmental concerns such as permitting for ECAs and emissions reporting for OREG 127 or MPRI. So if you're venting out the facility air, you would need a permit to do that. Some people don't do that by keeping within the facility and doing some sort of filtration to reduce those contaminant levels before reintroducing it to the facility. And again, with that, you'd want to be careful because you got to make sure that the air is suitable to reintroduce. So doing a sampling study pre and post would be recommended. Administrative controls, you have reduction of work periods or rotation through different process zones or possible reassignment to different work areas. So what you're doing is the worker is being pulled from an area and put into an area with less concentrations, so their overall 8-hour exposure will be reduced. So they might start out in the morning in one area where there's some contaminants and exposures, and then they're moved or rotated with other workers with the goal of keeping exposures below TWAs or STELs, etc. Housekeeping is important because you want to keep your work area clean. You want to immediately clean up spills, etc. So you're just keeping exposures as minimal as possible. Health surveillance, you might have occupational hygiene testing, which we've talked about. You might also have medical surveillance for something like designated substances or audiometric testing. And these are useful because you can see the person's sort of response or their health over time while working at the facility. And it's really good to have a baseline before they start, and then periodically over their time at the facility. And finally, PPE. You want to use this as a last resort. If all other reasonable precautions and practices and controls have been implemented, but still the air contaminants exceed the limits or health concerns still remain, then PPE is required. These might be respirators or hearing protection, but you need to at least have tried to introduce engineering or administrative controls. So you're not supposed to just jump right to PPE. You should demonstrate and keep it in writing that engineering and administrative controls have been tried, but PPE is still required. Worker education training on PPE is very important. So they need to be able to know how to use it, to wear it, maintain it, etc., in order for it to work, because it's their responsibility as well to use it properly. So integrity and fit are critical, and something like respirators need to be fit tested with the specific unit that the worker is assigned to. So it can't be a demo unit. It needs to be the specific unit they're using. And you need to adhere to the manufacturer's replacement schedule for something like the cartridges, the air purifying cartridges, or the hearing protection. So for inhalation, we have respiratory protection. The respirators are selected based on the hazard and the respirator's capabilities and limitations. You need to know the MUC, maximum use concentration of the respirator, which is calculated using the OEL and the assigned protection factor of the respirator. You need to know what you're protecting against. Is it dust or biologicals or chemicals? The respirator might be just an air purifying respirator, which has filters, such as seen at the bottom here. There might be a HEPA filter or some sort of material to absorb VOCs, for example, or acids. You might have a respirator that's air supplied, so it's clean air from outside of the work area, and it's important that worker education and fit testing occurs. So the industrial hygiene guidelines state that every employer shall take the measures required to limit the exposure of workers to a hazardous biological or chemical agent in accordance with the following rules. So if the agent is listed in the Ontario table, you cannot exceed the TWA stellar ceiling. And if it's not listed there, then you need to consider the ACGIH table for those limits. And as stated previously, you might find other resources for reference, which would not be enforceable from OSHA or NIOSH, for example. So some OEL updates for the last year. Every year, a number of compounds and OELs are reviewed by Ministry of Labor or ACGIH. In 2017, there was about 43 compounds under review by ACGIH, and this year in the booklet, it's about 25 compounds. And just a couple examples I pulled from that, which are considering some changes. For Ontario, they might be going to actually introduce the TWA for formaldehyde of 0.1. Currently, we just have the STEL and the ceiling, and so those would be some changes for formaldehyde. For styrene, just another example, a reduction from 20 ppm down to 2 ppm for the TWA. So you would just want to refer to these resources annually and just keep on top of the changes that come about every year. Just some other changes from the Ministry of Labor. You can find these in the Green Book. Worker at Heights training took effect 2017. Bill 177, the Stronger Fair Ontario Act, has steeper fines for infractions, new limitations established for bringing a prosecution under the Act, and reportable incident for structural inadequacies. You might want to refer to each of these different regs listed here if they apply to you. OREG 381, just noting that it used to be under the industrial regulation, but now it applies to all workers. OREG 833 has a few updates. 851 has some updates, as well as the construction and mining regs. They have some updates as well. So there's too many to list, but it's just good practice to be checking on these yearly and even just ahead of time to see what might be coming down from the government to get ahead of it. That's always recommended, to know what's coming so you can be prepared for that. WMIS and GHS, Bill 85 was introduced in 2015 and took effect in 2016, and that's regarding the new GHS system. And there's online training for that available. And that is the end of the presentation. And thank you very much for listening to that. And if you have any questions or would like to have a discussion, we can do that now by adding your questions to the chat, or we can unmute you and we can have a discussion directly. Thank you very much. Here's my contact information. And if you have any other questions, you can also call me directly.